In this section of notes, we are going to talk about independent and dependent events. And we're going to kind of take this concept and use it in the next section as well. And before we get started, we kind of need to know what an independent and what a dependent event is. An independent event is simply when the occurrence of an event has no effect of the probability of another event. Okay, so one thing does not affect the outcome of another thing happening. A dependent event is when the occurrence of an event does affect the probability of another event. So one thing does affect whether or not another thing is going to happen. So independent event, how I like to think, there is no change. So independent, there's no change. Dependent, there is a change. Independent, nothing is changing. Dependent, something is changing. And as we go through these examples, we'll see some trigger words that will help you decide whether or not events are independent or dependent just based off what's happening. And that's what we're going to do in this first example. We're going to determine the following scenarios as having events that are dependent or independent. And we're going to explain our reasoning with each one. So we take a look at A. So the person pulls a red marble out of a bag that has 5 pieces of red marbles and does not replace it. Then a person pulls another red marble. So first we're going to kind of do the long-handed way and do the math to determine whether or not the events are independent or dependent. But there's actually some words in this scenario that we can decide on whether or not they're independent or dependent just based off the words. But let's first do the math. Okay? So we think about it. The first part of the scenario is a person pulls a red marble out of a bag. Well, let's find the probability of getting the first red marble. Well, the total amount goes in the bottom, and if there's 5 blue and 7 red, 5 plus 7 is 12. And of those 12, it said 7 were red, so 7 is going to go on the top. And if it helps to put it in a percent, just do 7 divided by 12, which is about 0.58 multiplied by 100, so it's about 58%. Well, let's then, the second part of this scenario is then a person pulls another red marble. But they do not replace the first one. So if they don't replace the first one, that means there's 11 marbles now in the bag because they took one out and didn't put it back. And the marble that they didn't replace was red. So now instead of having 7 red marbles, there's 6 red marbles. And as a percent, if you do 6 divided by 11, that's about 54.545, which is about 54.5%. And you move that decimal point over twice or multiply by 100. So as you can see, there was a change. There was a change in the possibility of picking a red marble because they did not replace it. That is a big phrase right there, did not replace. Whenever that happens, whenever you don't put something back, that's changing the outcome. And because there's a change, that means the event is dependent. So your answer would be dependent. And your reasoning would be did not replace first marble. So by not replacing the first marble, you're changing that possibility of getting a red marble on the second try. So whenever you see the word does not replace, does not put back, things like that, the event is automatically dependent. Because you didn't replace the first thing, you're changing the outcomes and changing the possibility of picking another thing. Okay? So now you don't really have to do the math in these scenarios, you're looking more for the words. we take a look at B. It says a person flips a coin and notes that it comes up heads. Then the person rolls a standard six-sided die and notes that it comes up as a number less than 3. Well, if we think about it, to determine whether or not these are dependent or independent. So the person flips a coin and it comes up heads, and then they roll a die and it comes up as a number less than 3. Ask yourself, does flipping a coin have any effect on what the dice is going to land on? And the answer is no. The coin has absolutely no effect on what a die lands on. Just because you land on heads doesn't mean the die is going to land on a 2. Okay? They're two completely unrelated things. So because they're two completely unrelated things, we would say that these events are independent because there's no effect. Okay? You would say the coin has no effect on the die. Okay? They're independent, and that's the definition of independent events. One event has no effect on the other. Well, this is 2 events. Coin has no effect on the die, so therefore they're independent. So if they're 2 totally unrelated things, they're going to be independent. If we look at C, it says Owen picks an apple from a bowl of fruit and eats it. Then he picks a banana from the bowl and eats it as well. Okay? Well, if we think about it, the first action Owen's doing is he's picking an apple up from a bowl. Okay? Whenever you're removing something, ask yourself, did they put it back? Because if they put it back, that's not changing the outcome of them picking a banana. Okay? Because you have the same amount of fruit still in the bowl. But a big trigger word here is he took the apple and he ate it. Okay? So by eating the apple, you're removing it. You're not replacing it. I hope that you wouldn't eat the apple and then put the core back in the bowl. That'd be kind of gross. But technically, by eating the apple, that's not replacing it. So whenever you see a scenario and someone's taking something from a bowl and eating it, okay, it's automatically going to be dependent because they're changing the outcome of picking a banana. We don't really know the amount of fruit in the bowl. Doesn't matter. It's dependent. He ate the fruit. Did not replace. Which means they did not replace. Whenever you don't replace something, it's automatically dependent. In D, it says Chris picks a chocolate chip cookie from a jar, decides he does not want it, and puts it back. Then Chris picks a sugar cookie from the jar. Okay? Here we don't have to do any math in these scenarios. We can just read the scenarios and decide whether or not they're independent or dependent. And the big thing here is he didn't want the cookie and he put it back. So by putting that first cookie back, that kept everything the same. Didn't change anything. Had no effect on picking that sugar cookie. So because there was no effect, because he replaced the first cookie, these are independent events. Replaced the first. So whenever you put something back, whenever you replace something, it's going to automatically be independent. This last one says Mrs. Collini needs 2 students to help her with a math demonstration for geometry class. She randomly chooses one student who comes to the front of the room. Then she chooses a second student from those still seated. Think about it for a sec. And I would say that this would be dependent. Because she called a student up to the room, okay, which means she did not replace the first student. Now, if she picked a student and then that student sat back down, Then it would be independent because the student was replaced back to their seat. Okay? So here it's dependent. Student did not, or first student, I guess, first student did not sit back down, was not replaced. So whenever something's not replaced, again, it's always dependent. To sum things up, without replacement, eats it, doesn't put it back, things like that, means the events are always going to be dependent. So whenever there's no replacement, dependent. With replacement, puts back, replaces, means the events are going to be independent. And then lastly, two events that are unrelated, like rolling a die, flipping a coin, those are going to always be independent as well. So just look for those kind of important words to help you decide whether or not events are independent or dependent.